Welcome back to the hyperbolic coding chamber. It's me, your host. I'm gonna keep it a $1,000 today, gang. Yesterday I ate some Taco Bell, and let's just say I just got the rest of it out of me just now. So the people over at the Taco Bank institution need to look into the ingredients because my body was in a crisis alert. Okay, so that was a problem. So the people at the Taco Bank need to look into that because my insides are still recovering and I'm looking into getting some organs replaced due to the damage that was caused. So Taco Bank needs to be looked at. But you know what? They got it figured out. They got tacos figured out. So I'm going to be honest, we have more tacos on the way. So hopefully whatever happened yesterday does not happen today. But yeah, a necessary evil to ingest more tacos. But you know what's more important to ingest? Comments from our fellow friends. We have Shubham Verma here saying which keyboard you're using. Right now I'm actually using the basic MacBook Pro keyboard, but I have a few different keyboards. One of them, I have this Ghetto HHKB. It's not the best. I bought it because I thought it would feel really nicely. But the best keyboard on the planet is the BTC 5100C. It's a keyboard from a millennia ago. Aristotle and other philosophers actually used it to write their books. And you can tell that this is true because the connector is not even packaged correctly. So, I mean, you need a papyrus to USB connection to actually make this work. So that one actually doesn't work too well. So I'm looking into making that make sense. But yeah, that's the keyboard. So I usually use a BTC 5100C every day, but it's the white version or the weird off-white version that old computers used to look like. We also have a comment from Island Eagle saying saw dude in return. And then we have Urevix, how and when did you learn to code? Can I code? It's unclear if I can code. It's unclear if my ability to code exists. But I did a 4-year degree at a local college for computer science, and we learned C++ there. And then, yeah, that was probably the real practice. But most of the practice was actually outside of class, making some wacky applications and games. First, I used to use Objective-C, and then I switched to Swift. And then I tried to use Unity, but I couldn't make it make sense. I'm really a Swift person. So Swift is the ideal language. But yeah, so I guess, yeah, that would be the ideal. So yeah. And we're back once again. I've noticed we've been doing a string of shorter LeetCode sessions. And yeah, it's interesting because when I look back on the videos, it seems to just be a necessary evil. It does seem to be that part of the grind is knowing when to step on the gas and knowing when to take the foot off the gas. So yeah, it's just been that way. So it's just been interesting to see. So hopefully we can keep that going, and things have been progressing. We're almost to day 200, almost 200 days of consistency. Hopefully the ripple effects will continue to be present. So So we're going to do some more LeetCode today, and we're going to do around 20 to 25 minutes, and hopefully we can we'll do 30. Hopefully we can make things make sense today. Yesterday we spent a whole bunch of time doing a problem that frankly was very simple, but the wording became really confusing because I pretty much misinterpreted a test case. So hopefully we can prevent that from happening, and we can return balance to the 4 nations. So yeah, we're continuing to make progress. Hopefully we can continue to make swift progress. So we're just going to jump into it today. And oh wait, I'm just realizing now we forgot to do the weekly suffering 316. Maybe we'll do that tomorrow. Yeah, maybe we'll do that tomorrow. I'd like to get back to the morning sessions. Oh, the morning sessions were a dream. Someone has to say it. Those were the good days, the good old days. Maybe we can get there. Maybe we need to figure out a way to wake up early. This was the issue. I think we had a comment before where someone said staying motivated and something like that. And I was saying that it's good to have a plan for redundancy, because I was able to wake up early for about 2 weeks straight because I was motivated to wake up early. Then the motivation waned and I stopped doing it. So there's always a plan B. I think it's just important to have a plan B in those scenarios that we don't end up making mistakes like that. Not mistakes, but yeah, I think it's just important. Because now I'm no longer waking up early now that my motivation has waned. So maybe we can make more sense of it in the future, where there just has to be another way to wake up early. That makes sense. I'm thinking of there's a wristband you can buy that will literally shock you to wake up. And I'm thinking that might be the wave. So maybe I'll buy that. And yeah, I don't know if I'll be alive depending on the shock it gives, but hopefully it's not too bad. So that would be the goal. And yeah, we're just going to jump into it for today. So we have 30 minutes on the clock. And we did find pivot index yesterday. The runtime was actually quite bad. 494. Something seems off about that. Maybe because I have console.log. There's no console.log. Yeah, I think it might just be because we're doing n squared. Is there a way to do this in linear time? Actually, you could do this in linear time. You could just keep the running sum in every indice. That way you wouldn't have to do process pivot, and you could just check if the sums are similar. For example, 6 would have 6, and this index would change to 11, and this index would change to 17. As for this would change to 1, this would change to 7, this would change to 8, and then this would change to 11. The question is, how much would that change? Because you'd still have to do the processing part. Could you just go through each index now? You could just iterate through the indexes, check the pivot, and check the values to the left and right hand side. Is that what you would be able to do? I wonder if that is what you could be able to do. Hi, 6. It's unclear, actually. You could create 2 arrays, one iterating from left to right, which would store all the values as a sum going forward, and you could do the other one from right to left, so that when you check the right-hand value, you're able to check the entirety of the right-hand side. I think as we realized in this one, you are just checking the right-hand side. So in another way, it's all the numbers to the right-hand side. So we could just have a value that gives another array, which gives us the value of all the numbers at an index without having to do this for loop. Then the process would just become iterating through these 2 arrays and finding where the 2 values are right next to each other. So you could probably take it a step further and layer another optimization on top. I think what I'm talking about is that if we look at this one as 1, 7, 3, 6, 5, and 6, we could do is create 2 more arrays. Why can't I zoom in? You could do is create 2 more arrays, so we could have something. This array would be the sum processed left to right. So we have 1, 8, 11, 17, 22, 28. Here we end up with 6 total elements in the array. and we would have the same thing but in reverse. This value would be 6, this value would be 11, this value would be 17, this value would be 22, we'd have 6, 11, 17 plus 3 would actually give you 20. Then we'd have 27 and then 28. Then the problem just becomes about iterating through this array in linear time and just checking if the index in the first array plus 2 is the same as the index in the other array. Now, does that make sense for the remaining? What's going on here? Does that make sense for the other ones? The other thing, all we have to do is make sure we include checks for 0. Yeah, all we have to do is include checks for 0 as left sum and right sum at the end. So it is possible that this could make sense, but checking from the end point. So I think we could write this function. So we delete all this stuff up here. Then we'd have left r, which would be the sum of the elements going from right to left, and we'd have right r. Here we could iterate for left r, we're going to have a value called cur_sum left, which would start at 0, and the same thing cur_sum right, which would also start at 0. And the difference would be that cur_sum left would always be plus equal. We'll change the pivot to I so that we don't get confused by the variables. Say cur_sum plus left plus equal nums sub I. Now, once we have that value, we can do, actually, we want to start both arrays. Actually, no, we'll just do cur_sum plus left, and we do left r dot push cur_sum left. Now, the thing is, what should get pushed onto right r? We can actually use our starting number for our index to reflect over the other half of the array. So instead of doing cur_sum left plus equals 1, we can do cur_sum right plus equal nums dot length minus 1 minus I. Now that I'm realizing it, this would actually change. This would actually push this array in reverse. It would actually put it in reverse. So if we reflect it, I was gonna say we can just do right r dot push unshift, but then our unshift operation, because we're adding to the front, just becomes n squared. So we end up with n squared time anyway. And in fact, I think we could fix this if instead of pushing, we just set the values. So what if we just did something like this? We duplicate this array, we duplicate this portion right here, and then here we'll just set up the values. We'll just do left R push 0 and right R dot push 0. That way we can just put the values into the array. We can remove these push values because then what we just changed them to is left R sub I equals cur sum left. And then right R sub nums dot length minus 1 minus I equals cur sum right. Then we can print left R and right array. So we should just get two arrays, which are the sum of the elements. Oh, I still have a push in here. That's my bad. So it's still not working, which is fine. It's kind of what we're aiming for. We still end up with an end sum of 28, which makes sense. And we can just check the index up here, plus the two indexes forward to check if their pivot sum is the same, or if they have the same sum on the pivot. So then what we can do here we can once again do another linear time iteration over this and just check if left R sub I is equal to right R sub I plus 2 you can return I. Only problem here is that we could potentially go out of bounds. So we'll do nums.length minus 2 so that we don't go out of bounds. And we'll check the last one that we can actually reach. Which is going to be, for example, if we're at 17, the other side of the sum is just going to be 6. That's the most that we can actually get there. And the other thing we need to check is if we assume that our left sum is equal to 0, right, when we're at the left hand edge, then what we need to check is if left R sub 1 equals 0, for example, in this case, right? When it's this case, our left sum is equal to 0. So if what left R sub 1, which would be this index, equals 0, then we want to return 1, right? And if right R sub nums.length minus 1, actually minus 2, and we'll use safe navigation on both of these, equals 0, then we'll return nums.length minus 2 because we want to return this index. Okay, so we're still wrong. Our output is index 2. Zero, 1, I think we actually want to return right, and our pivot here would actually be 0 when this is true. I think this should also be nums.length minus 1. Wait a second, I think I have this bottom case right here messed up. So we need to fix this first. We have 2, 1, negative 1. So if we say left edge is equal to 0, and then we do right r I plus 2, this should have a sum of wait, I think our logic here doesn't make any sense. If we have a left array and a right array, which are pretty much sum arrays based on the direction that we're going in, this final case, we have 2, 3, 2 for our left array, which makes sense because we have 2, then we add 1, we have 3, we add 1, then we have 2. And this other one we have 2, 0, negative 1. How does left r sub I Oh no, we ended up returning negative 1. Okay, this makes sense because I was wondering, I was like, wait, our off case, I always get messed up and look at the output and expected and get confused. This makes sense. We're returning negative 1 because our code shouldn't have this problem here. Now we just need to fix our remaining case. I think what we're doing here is we swapped the cases incorrectly. If we do left r sub I equals 0, equaling 0, it doesn't really make any sense because left r sub I would be 3, right? And what we actually want to check is that when our pivot is index 0, our left sum is going to be 0, which means we want to make sure that our right sum equals 0. So what we actually want to check is that right r sub 1 equals 0. And if we look here, right r sub 1 does equal 0, so we can return 0. And then the same for right r. We want to make sure that when our pivot is on the right edge, right here, our right sum is 0, which means we want to check that our left r sub nums.length minus 2 is equal to 0. And then I'll add one more case to make sure that we test when our right sum is equal to 0. So if our right sum is going to be 0, right, how can we make a test case that makes sense? Right sum is going to be equal to 0, so we'd want to place 0 right here. This actually doesn't make sense because if our right sum is 0 and our pivot's here, this would actually make more sense because there's no answer in the middle. It's only when our pivot is the last element in the array, our right sum is 0. If we add these two up and check the element to the right, so if left r, so nums.length minus 2, so this should give us I think we can get the same effect if we do 1, negative 1, 1. Maybe it should be wait, I'm pretty sure this doesn't work. So our last test case just failed. When I make this 1, our output is 1. They're saying that the pivot where this makes the most sense, where the sum is the same, is 1. I think what I need to actually do is make sure that we get the leftmost pivot first, which means we should place these up here. For some reason, our output is 2 here, 0, 1, 2. I think we're confusing ourselves. We want to do I minus 1 if our pivot is I. So this is why we're confused. If we change this to pivot, I think the code makes a lot more, it's easier to see why the code doesn't make sense. If 0 is our pivot, it means it kind of only makes sense for us to start at pivot equals 1. That's the case, and we can say if pivot minus 1 is equal to pivot plus 1, then we can return this as the correct pivot. It's unclear why this is returning this value. If we do I as a pivot, we do left r sub pivot minus 1. So, I see. Because we're only going... We can do nums.length minus 1. I think that should fix it. Our output is 5, except our expected was 4. I see what's happening. We're getting the correct answer at the left or right hand side here. We need to place not these two. We need to separate them. We just learned an important lesson there. Now it's the last test case remaining. Now when there's one element in the array, we can just add another case up here and say if nums.length equals 0, return 0. I mean, if nums.length equals 1, return 0. There we go. So that would be linear time with linear space. Okay, you know what? I'm not gonna lie. They beasted on us with this solution. Of course, if you know the sum of the entire array, then you can just subtract the sum of any individual index and you'll know the sum for the remaining. No, actually that's not true. You had to, not the sum of the whole array. You needed to know the sum of the whole array and the current running sum, because the whole array minus what you ran through already with the left sum minus the current pivot would give you the right sum, and that's exactly what they do. They take the sum minus the left sum minus num sub I, and then if that's true, you can just return I. Oh man, but that's not bad. We got it to linear time, except with linear space. This person said the same thing. I used 2 extra arrays, so that is unfortunate, but a necessary evil. And yeah, I'm glad we already wrap up this problem. That was a fun problem to optimize. We have find tic-tac-toe winner, and I think we should be able to do this one, but we only have about 40 seconds remaining, so I'm just gonna wrap it up there.